Hi everybody, my name is Jonathan Zhang from Facebook. I'm going to give the OSF status on OCP server DeltaLake. The agenda will be first, I just give an overview and the context, and then we will talk about the engineering process for us of how we trying to get the right engineering process in place to get to production grade. Then we talk about our quality assurance and the current status, and then call to action. This is an overview of Facebook's OSF open source or open system firmware stack. Mainly in the firmware, we have three parts. One part is the FSP provided by Intel. Another part is core boot, which is open source project, and then Linux boot. Linux boot has a Linux kernel that's just a regular Linux kernel, plus init-run FS. In our case, the init-run FS is uroot. Our philosophy is that we do upstream first, and we share the same Linux boot image for all Facebook platforms that runs OSF. And we share the same core boot code base for all platforms, only differentiated by kconfig. This was a presentation given in March of last year. That was when we started to work on this on OSF for compute platform. We do have OSF for other platforms that's in production. So on the computer platform here, we talked about what is Facebook doing and why, and what's our build system design, and how we enable the partners and the community. In the virtual summit of this year, half a year ago, Brady from Intel and myself gave updates on the Xeon SP, FSB, and the core boot status. We will actually give a status again at 3 o'clock. This is another presentation that I gave together with our partner Winwin, Johnny Lin from Winwin, on what features we are working on with core boot and Linux boot, what the designs are, and where the status, where they are. So here's an overview of the OSF effort in Facebook infra. We have Arista switch, that's a network server that is in production. It's one socket. It runs on Broadwell DE and FSB 1.0. So on the computer side, we had a proof of concept on MonoLake, and then a proof of concept on TilgaPath. Now we are working on DeltaLake. And the DeltaLake is on Intel Cooper Lake SP processor, which will be mass production in 2021. Now we switch to the engineering process part. So we have a 4-week cadence of build, test, and release cadence. So Intel, so at the first week, Intel releases FSB. Facebook ingests the FSB release and sends the release to ODM. So normally it would comes with a core boot change. Then we send a PR to the upstream, and then ODM build the release candidate with with the new FSB, a new core boot patch, and possibly a new ME and macro code. The second week, ODM provides a test report of the previous cycle and starts testing of this cycle. At the same time, Facebook makes internal releases based on the previous cycle test result. The third week and the fourth week, ODM runs testing. So that's our engineering process. We just iterate this process. So we normally get FSP every 2 weeks instead of 4 weeks. So then in our release process, why do we do it every 2 weeks, every 4 weeks instead of 2 weeks? Is that we still want to ingest every FSP released by Intel so that we can find a regression sooner and we can validate the new features and the bug fixes in the FSP and in core boot. And sometimes the release might be late. So we sometimes have to use the older release. So that's why we ingest every 2 weeks. When there's issues with FSP, the resolution steps is that first Facebook debug the issues and analyze the feature gaps, and with a support ticket with Intel. And Intel triage the ticket and provide patches as necessary. We validate it, and then Intel would incorporate it in the later release. Our model for both core boot and Linux boot is upstream first. So today, if you just build from core boot upstream and Linux boot upstream, that's exactly what we use for our engineering process. We have nearly 0 out of tree patch. When I say nearly, is that sometimes when we, for example, when we just get a release, we would have an out of tree patch. As soon as that is merged in, we don't have out of tree patch anymore. So this is a screenshot that when I get Intel week 40 release, I send a patch to the upstream community. This is a documentation of the core boot documentation for the DeltaLake mainboard. And this documentation is updated upon every build, test, and release cycle. We document what works, what doesn't work, and what is planned, being planned on. We also emphasize the automated tests. So today in the core boot upstream merge process, at this moment, only build tests or members are merged prerequisite. We are working on targeted test. And we are also working on Facebook acceptance tests for ODMs and the Facebook internal automated tests. So those Facebook acceptance tests will be pretty much the same for the traditional firmware and for OSF. The only difference is if those two different approaches require different steps. And our ODMs runs a lot of tests for us. There is a sanity test, and there's a full test report. So now we go to the third agenda is quality assurance. So this table shows that during the process, we worked on 3 different platforms to polish the OSF technology. With MonolLake, we did a test. At the end, we did a test at December of 2019, and the pass rate was 18%. And with TiogaPass, we did a test in May, and the pass rate was 37%. With DeltaLake, this is the data of August. We have new data upon every cycle. So the data as of August was 57%. So this is a list of what we test. The green ones are the ones that passed. And the other one is passed with some issues. So we test the firmware upgrade, downgrade configurations, info display, bootloader, SM BIOS loader, ACPI tables, and OS command and logs, OpenBMC command, and the UEFI foreign firmware test suite. So we analyze each and every firmware test suite test result. Some may not be applicable, and we get signals from that. On the stress test, we do reboot stress test. We are able to pass 1,000 cycles without a major OS problem. We do stress test, M prime, PTUGN, and BIOS flush loop. That's all passing. Performance is key to us. It's a very critical signal for us. On the performance side, at this moment, we have a better core CPU performance. The I/O performance is on par with traditional firmware. At this moment, we have some issues with the memory performance, and that we are working on it. Actually, with OSF, we found that we actually provide 200 meg more memory to the OS, so that's a bonus. Power and thermal. So we pass all the power and thermal tests for the temperature sensor reading, and all the memory hot, proc hot, and power consumption. Security and ROS. So security and ROS, most of the security and ROS features are under development. We have TPM passing. We have the TXT under converged boot guard and the TXT being worked on. And the boot guard profile 0T being worked on. Regarding memory ROS, we got basics working. We still have some issues to be worked on. Our next step, what we are working right now, is mostly focusing on the PCIe ROS. So this is the last slide. It's on call to actions. The OCP OS project has meetings every 2 weeks. So please join, and if you are interested, and you can join core boot and Linux boot development. Also, for the if you want to just try it out, you can buy off the shelf Tioga Pass, and then then if you get the ME binary and FSB binary from Intel, you will be able to build and try it out yourself. This is the end of the presentation. Now let's see if there's any questions. Feel free to ask any question, please.
I didn't see any questions, but one question I had was, if I were to buy my own Tioga Pass, how much would that cost?
So when you buy Tioga Pass, it comes with the server itself, and then it also comes with a power kit. Because the regular Tioga Pass that, for example, used in our data center is something you can just directly put into a rack, right? So when you buy one, you need a power adapter that allows you to plug into the wall. So that power adapter, it can drive 3 servers. So the server plus the power adapter together, because I don't want to speak for for Winwin, but it's something around 6 to 7K, or around that range. Don't hold me accountable, but it's around that range. And it's a dual socket. Skylake SP processor.
Makes sense. And you said you'd also need, in order to use core boot, you will also need the FSP and an ME.
Yeah.
And those aren't available yet. Is there any idea when?
Those are not publicly available. If you have a business arrangement with Intel, we can get it.
Yeah, that one, I mean, the FSB binary, it started off as the POC code. So that's one of the reasons why it's not publicly available. Having said that, we are looking at, if there are specific customers who are interested in taking the OCP Tioga Pass board, deploy core boot on top with Intel FSB for the OSF badging. That could be one of the triggering points for us to take a look at and see if we want to, have the FSB binary available publicly. But there is some work needed, primarily because it's a POC code. It doesn't really work very well on the 2-socket beyond, just booting. So we'll have to essentially look at, do some hardening work, stability testing and everything. Hopefully using the Cooper Lake FSB source code as the base, then build and harden the FSB for the Skylake Tioga Pass board. Then it may be worthwhile pursuing making it publicly available. The problem with the beta code is, right, there will be a lot of, we don't want to give something that's poor quality and then it's really, bad experience. So there is that, concern. So in general, we want to do the hardening and then actually make it available if there is a need for it for the Skylake FSB.
Yeah, thank you, Reddy. There are some good questions. There's a question from Jim asking that how do you explain the performance decrease from the memory? Aren't you using the same Intel MRC code to initialize it? Yeah, we use the MRC code is in FSP. So at this moment, we are still debugging it. We don't know where the problem is. We looked at every aspect of the CPU frequency, MSR setting. We have not found where the issue is yet.
Yeah, so I mean, the initialization piece goes through FSB. So the MRC unit actually uses the same thing between the full RP versus FSB API route or even FSB dispatch route. They all use the same common code. So we are not suspecting anything to do with the Intel MRC code. It is more to do with there are several PCD settings that are actually not available in the Min platform. And compared to the full reference platform PCD settings, there could be a set of PCD settings that are influencing either the frequency aspect of the core or the frequency aspect of the uncore or something to do with the memory side of the settings. So we are essentially looking at those aspects.
Yeah. There is a question about the test content. It's like what test content we run, will that be able to be used by the community? At this moment, almost or pretty much all the test contents, well, I shouldn't say that because we also have automated test automation. Most of the tests are done manually. So they are done by the ODM test team. I asked them to add a lot of the test content to the firmware, which they previously only do it for the system level testing. Yes, it is a goal to grow the automated test and grow the automated test that is available to the community. We are working on it. On core boot infrastructure, upstream community infrastructure, we are going to add test report for TiogaPath and DeltaLake. You will be able to see it soon. In the beginning, it will be basic tests, and then it will grow from there.
So Jonathan, can you speak on the DeltaLake board specs being available for OCP, and then your thoughts on the OCP badging process in general for the Facebook platforms? It doesn't have to be DeltaLake, but just the broader question.
Our EE team works on the, so DeltaLake is a blade in the Yosemite V3 sled system. So Yosemite V3 is a multi-host system. Our EE team are working on the design specs for both the Yosemite V3 system and the DeltaLake board. We have gone through multiple iterations. I don't know the exact schedule. I would guess that sometime next year, around the time that the Cooper Lake SP processor goes to mass production, we will submit the hardware spec, design spec to OCP, and in the same time, we hope to submit the OSF code base to OCP. The code base would only involve, will be just upstream as is for core boot and for Linux boot, plus some build system stuff, and then the rest things like the FSB binary and ME binary and microcode, and those would come from Intel.